so this is chapter 11, section 3, and we're going to do the probability of multiple events. So not only the probability of being a good student, but being a good athlete. Those kind of things where we're combining items. So our learning objective is to find the probability of event A and B, and to find the probability of event A or B. So please note that we'll be doing and or. When the occurrence of one event affects how a second event can occur, the events are dependent events. Otherwise, the events are independent events. So if the occurrence of one event doesn't affect how the other event can occur, then they are independent. So I'm going to show you an example, and then we'll do the got it one. The got it is one I want you to write down. All right, so let's look at a couple of scenarios. And we're going to look at, are the outcomes of each trial dependent or independent events? So if I roll a number cube and then spin a spinner, the two events do not affect each other. They are independent because they're not even you're not even touching the same item for each of these events. So they are definitely independent. So the second scenario is if you pick one flashcard, then another from a stack of 30 flashcards. So these two events are dependent because the first scenario, you picking one card, reduces your amount of total cards for the next pick to 29. So by picking one flashcard and not replacing it, you are requiring the second event to change according to the first event. So these guys are dependent. And then let's look at this got it question. You select a coin at random from your pocket. You replace the coin and select again. Are your selections independent events? Explain. So in this scenario, I would definitely say that these are independent events. Let's write in complete sentences so that we act civilized. These are independent events because you replace the coin and restart the selection process. All right, so definitely we're going to write this down. Multiply to find the probability that two independent events will both occur. So the probability of A and B. So these are independent events. P stands for probability. Event A is the first one, event B is the second one, is equal to the probability of event A happening times the probability of B happening. So let's take a look at the example, and then we'll do, I definitely want you to put this got it in your notes. Okay, so at a picnic there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, eyes closed, what is the probability that you get a diet drink and fat-free chips? So we're going to find the probability of event A picking a diet drink and the probability of event B picking fat-free chips. They are independent of each other. So we can multiply those two probabilities together to find the total probability. So you take the number of diet drinks, which is 10, divided by the number of drinks, which is 15. And then the number of bags of fat-free chips, which is 8, divided by the total number of chips, which is 20. Wait, that says 12. Oh, because that's 12 regular. 8 fat-free and 12 regular give us a total of 20. That gives us 80 over 300, which gives us 4 over 15. And that's approximately equal to 0.267 or 26.7%. So the probability that you get a diet drink and fat-free chips is about 26.7%. So let's see if we can get this concept to make sense for us. In problem 2, what is the probability that you get a regular drink and a regular chip? So the probability of regular drink and regular chip. This does not say dip, it says chip. Doesn't say drip, it says chip. Is the probability of regular drink times the probability of regular chip. So the probability of the regular drink is, there's 5 out of 15 total, times the probability of regular chips, which is 12 out of 20. I'll just do it. So 5 goes into 24 times, goes into 5 once. 4 goes into 12 3 times, goes into 4 once, and 3 goes into 15 5 times, and into 3 once. That's 1/5. Which is 20%. So there's a 20% chance you'll get regular chips and regular drink. Why isn't this, if the probability that I'm getting diet drink and diet drinks, or diet chips, why is that 26.7%? Why is this probability not 73 point, why isn't it this minus 100%? Why isn't it in that 70% category? Doesn't that take care of the rest of the scenarios? Yeah, 73.3. So why is this 20% and not 73.3? What do you think, Crystal?
Because we're not just adding the variables together, we're seeing the variables as independent.
So the reason that this is 20% and not the 73.3% is because you could get a regular chip and a diet drink, or a fat-free chip and a regular drink. So there's 2 other scenarios that need to be represented here to get us to that 100%. Good job. Good thinking skills. All right. That's the scenario where the 2 events are independent of each other. Now we start getting into a little bit messier situation where 2 events that cannot happen at the same time are mutually exclusive events. If A and B are mutually exclusive, then the probability of A and B happening at the same time is 0. So what's the probability that Leah is here in class right now? And what's the and on the moon? Since those events cannot happen at the same time, the probability is 0. So I just want to look at these events. You are going to write down the got it events, and then these are just for your viewing pleasure. mutually exclusive events. You roll a standard number cube. Are the events mutually exclusive, and explain? Rolling a 2 and a 3. Cannot roll a 2 and a 3 at the same time. The events are mutually exclusive. Now let's look at the second scenario. Rolling an even number and a multiple of 3. You can roll a 6, which is an even number, and a multiple of 3 at the same time, so the events are not mutually exclusive. Those two can happen at the same time. So now let's look at this scenario. Let's see if we can reason this through. You roll a standard number cube. Are the events mutually exclusive? And let's explain. Rolling an even number and rolling a prime number. So if you got a number cube, your even numbers are 2, 4, and 6. Are any of those prime?
Yes.
2 is prime. So these are not, since 2 is a prime number, these are not mutually exclusive. All right, let's try our second scenario. Rolling an even number and rolling a number less than 2. Are those mutually exclusive? Are there any numbers that are less than 2 that are not? So for B, since there are no numbers that are even and less than 2, these are mutually exclusive. So if the probability is 0 of that happening, then you're mutually exclusive. Okay, so to find the probability of either event A or event B occurring, you need to determine whether the events are mutually exclusive. So you can only use this probability if they're mutually exclusive. So the little formula says probability of A or B is equal to the two probabilities added minus the probability of them happening together. If they're mutually exclusive, then it's just the two probabilities added together. Because in order to be mutually exclusive, the probability of A and B is 0. It's in the definition. So this is a big, important concept. And just to remind you, we wrote how to find this down, probability of A and B. It's right here. The two probabilities multiplied together. So just to remind you. So we need to determine, are they mutually exclusive, because the formula changes based upon whether they are or not. So let's look at a sample problem. I have to write this down. At your high school, a student can take one foreign language each term. About 37% of students take Spanish, 15% take French. What is the probability that a student chosen at random is taking Spanish or French? So are they mutually exclusive? And let me highlight this right here. A student can take one foreign language each term. So if they are in Spanish, they cannot be in French. So these are mutually exclusive events. So we can use the formula probability of A or B equals probability of A plus probability of B. So we take our percentages and and we add them together. So 37% plus 15% is 52%. So the probability that a student chosen at random is taking Spanish or French is about 0.52 or 52%. All right, let's do this together. No, don't write any of that down. What we start down is, I want you to write 9% take Mandarin Chinese. What is the probability that a student chosen at random is taking Spanish, French, or Mandarin Chinese? So the probability of Spanish or French or Chinese is equal to the probability of Spanish plus the probability of French plus the probability of Chinese. So that is 37% plus 15% plus 9%. And that is equal to 0.61 or 61%. Because they're mutually exclusive, we can just add them straight across together. There we go. So here's the other scenario. When two events are not mutually exclusive, we need to subtract out the probability of the common outcomes. So let's look at an example of that. Suppose you reach into a dish and select a token at random. Here's our little variety of tokens. What is the probability that the token is round or green? So the probability of round or green is the probability of round plus the probability of green minus the probability of round and green. So you look, the probability of selecting a round one is, there's 1, 2, 3, 4, 5 round ones in a dish of 9 altogether. So they get 5 nines. And then the probability of green is 1, 2, 3 greens out of 9 total, minus the combined probabilities, the probability of round and green, which there's only 2 round and greens. So 5 nines plus 3 nines is 8 nines, minus 2 nines is 6 nines. So the answer is 6 ninths or 2/3. All right, so let's do this for our scenario. So this is what you write in your notes. Suppose you select a token at random from the dish above. What is the probability that a token is square or red? So we want the probability of square plus the probability of red minus the probability of a square red. So the probability of being a square is 1, 2, 3 out of 9. Plus the probability of red is 1, 2, 3 out of 9. Minus the probability of being square and red. Just 1 square red. 3 ninths plus 3 ninths is 6 ninths, minus 1 ninth is 5 ninths. All right, let's do the same scenario, but with green. So we want the probability of green plus probability of square minus probability of green square. So the probability of green is 3 out of 9. Because there's 1, 2, 3 of them. Probability of being a square, I know that, it's 3 out of 9. We already calculated that. Probability of green and square is also 1/9. Did you guys get 5/9 again?
Yes.
Same?